am Suzanne Murtha. I work at AECOM, and I'm our global lead for advanced technology, and that includes connected vehicles, automated vehicles, advanced air mobility, and payment systems. And so in that role, part of the work that I do is to support the deployment of connected and automated vehicles. Here today, we're going to talk about a tool that we developed called AV-Readi. But before I dig into the tool, I wanted to share with you some of the work that led up to development of the tool. So a few years ago, pre-COVID, AECOM came up with the idea of doing an automated bus consortium. And so that means that we pooled the funds of many of our transit clients to put together the first ever procurement for highly automated full-size transit buses. This was important because at the time, there were very few transit agencies who could afford to invest in automation. There were even fewer transit bus manufacturers who were interested in supporting development of automation because they are dependent on the client requests. And so client requests in the US and in many parts of the world, transit vehicles are largely subsidized by the federal government. So they're not always in a financial position to be able to procure next generation technology. So we took this as an opportunity, and in the fall of 2018, we did an analysis and talked to the bus manufacturers and asked them what it would take to be able to create a market for automation. Another way of saying that is, how many bus orders would it take for the bus manufacturers to start considering automation as a service they would offer? The answer they gave to us was if they could get an order for between 75 and 100 buses with automation in it, that they would be able to invest in the technology. So we set about trying to assemble an order of that many buses with our existing transit clients. So at the time, so we were largely successful. We have at any given time had about 10 members in our consortium. That number, dipped largely during COVID because transit industry generally was decimated during COVID. So we had a little bit of a slowdown. And so now we are here in 2024, and we're going to do our second round of procurement. And maybe more importantly than our procurement is since we undertook that work in 2018, we've seen a ton of automated bus opportunities pop up throughout the country. So other transit agencies have seen this as, as an opportunity that maybe that this is something that they could do. So we're very proud to have been one of the first companies and first organizations to do automation in transit. And so this is what I'm describing is one of the outcomes of our work. When we talk about automated transit, one of the important things to look at is levels of automation. You'll notice that I did not say the word autonomous. Autonomous is not a defined word in SAE standards. The technical term is automated, and there are levels of automation. 0 being no automation, that's what my car has, and 5 being full automation. Full automation is when a vehicle can operate level 5. It's called level 5. It's called full automation. Sometimes people say fully autonomous or autonomous. That's usually what they mean is full automation. Full automation is when a vehicle can operate anywhere in any situation, or the technical term for those situations is called operational design domain, sometimes abbreviated as ODD, operational design domain. And level 5 is when a vehicle can operate in any ODD without restrictions. The very, very challenging technical objective to meet. It may not even be met, will not be met in my career lifetime. It will likely not be met in my lifetime. So our goal for our procurement is level 4, and this is called high automation. Very interesting. A lot of people use the word autonomous, and there isn't a clear definition for that. So I'm providing you some clear definition for what some of these things mean. And the definitions that we're looking at here, by the way, are agreed upon by NHTSA. That's one of the modes of U.S. Department of Transportation that works with Vehicle Safety, and the Society for Automotive Engineers, or SAE. So these are their terms. So it's an agreed upon standardized term. High automation is level 4, and this is when a vehicle can operate inside its operational design domain, its ODD, without a driver. So that doesn't mean it can operate anywhere, just in its ODD. So for example, we see Waymo vehicles operating in San Francisco as robotaxis without drivers. They have a specific operational design domain where those vehicles can operate, and they can't go anywhere around the city. They have to go inside the specific domain that's laid out by the definition and by Waymo in terms of where they can go. It's not anywhere. All right, so that is what we want for our buses. We want our buses being able to operate in high automation in the specific operational design domain, generally without a driver or moving towards without a driver. And I'm going to tell you how we determine when there might not be a driver necessary. Okay, here we go. And I'm going to get to that in a minute. So before, I wanted to share about the value of our consortium. So the idea is that by doing the Automated Bus Consortium, we would be accelerating technology development and deployment, which we did, which was super exciting. We'd also be reducing costs so that each of the members and the transit agencies did not have to pay consultants or their own staff to be able to figure out how to do this 10 times over. So we're all going to learn from each other, and also going to increase demand for the tech. I want to show you some of the routes that we came up with when we were working on this originally. We're working on the Automated Bus Consortium originally. We worked with Houston Metro. We analyzed routes. So we went out and we drove the routes. We took video of the routes. Our staff rode on the buses to see what the routes were like, to see how complicated or challenging they might be for an automated vehicle. In Houston, this is an example route that we came up with that Houston is planning to deploy, potentially planning to deploy an automated vehicle. Likewise, Dallas area rapid transit was planning. This was one of their planned routes, involved Love Field. Again, we went out in the bus and rode the route and took video of it to help analyze, in order for the respondents to the RFP to be able to see what the route looks like and figure out if they could indeed automate a vehicle on that operational design domain or route. I also wanted to share, because generally in transportation, we are working really hard to achieve equity with regard to rural and urban environments. So we worked really hard to find a rural route, and one of our rural routes is with Michigan DOT. And this is interesting because this is bringing workers who out to a factory, and the factory is in a location where a lot of the workers don't live. And they didn't always have a way of getting to the factory. So we developed a route that would fit so we could automate that route out. Okay, so I'm going to start. The reason I'm doing this presentation, we're almost halfway through. It's a lot of buildup. I wanted to share a tool that we helped develop, that we developed. We didn't help develop it. We actually developed it, and we filed a patent for it to help analyze the roadways so that we didn't have to sit on a bus and do the analysis visually. We have a digital tool that analyzes the routes and quantifies how easy it is for vehicles to operate on those routes. Because we had done it for so many agencies, we figured there had to be a way to do it quicker. So one of the things that's important when we're doing route analysis is figuring out which type of automation we're looking at. So we developed AV-Readi to look at three main different kinds of movement of vehicles. One is passenger service, such as robotaxi, transit bus, and also goods movement. So when we think of 18-wheel vehicles moving on the road, we can do an analysis to how well that vehicle will perform on that road. They all have different capability sets, so we break out our analysis based on what is the capability of the vehicle as well, if the client would like that. All right, so here comes AV-Readi, enough buildup. So we have done analyses of roadways, and I'm going to show you some examples and how, but I wanted to give you an overview. We have done complexity maps in 3 countries for many clients. Over 10,000 miles of roadways we have analyzed around the country. So here you can see we've done it in California and Texas, a lot of Maryland. We've done a lot of Maryland roads, Illinois, and we have done Toronto and Michigan, and all kinds of different, in Hong Kong. We've done roadways. We've also done analyses for roads that don't exist yet. So you can see the sort of breadth and capability that the tool has. So let me tell you more about the tool. So we analyze by roadway segment. So we figure out a route and figure out aspects of, by segment, so that we can do an analysis of the full road, but we can also figure out between traffic signals or between exit ramps if the road is a highway, for example. So we break down the roads into segments and see which makes the most sense. We can also assign a difficulty value depending on the capability of the vehicle. So we can do a typical automated driving system. That's what ADS stands for. Or we could do we could do it for a bus or for a truck, as I mentioned, or robotaxis. And then we have a calculation. We've built an analysis tool that we've done regression analysis on, and we've worked with 3 different automation vendors, all of whom say that our analysis and our predictive capabilities here are spot on with the tool. So we're really excited about that. So we have this quantification, and then we also have an interactive results dashboard, which we're really proud about too. So let me show you an example of, let me go through some of the examples that we have of output that we have for clients that we are allowed to share. So one of them is Montreal. So the city of Montreal called us and asked us to do an analysis of this roadway, which is right here on the left side of the screen. And we see that the output shows us that it's yellow. It's challenging. That means it's challenging. And so they asked us, well, what happens if we dedicate a roadway here only to automated vehicles? And, before I move to the screen on the right, I'll point out that automated vehicles do not need their own roadway. That's an important point that a lot of the vendors ask us to point out. It is not necessary. However, it is helpful in that it has fewer differences. So one of the most challenging things with regard to automation is for the vehicle to be able to pick up differences in the route each time. Each time it goes, there might be different things happening, different vehicles merging at different times, or different people walking in front of the vehicle. If you have a dedicated lane, the machine has to do less work to figure out choices that it needs to make. So it facilitates the route, but it is not necessary. So, however, in this case, in Montreal, we see that when we're able to break out an automated vehicle lane, it does make the route much easier for a vehicle to function on. Okay, so we had another client that asked us to talk about bus platooning. Now, automated bus platooning is very interesting because it is it's not helpful in a lot of cases. A lot of people ask us for bus platooning, and in reality, bus platooning is really helpful getting through the Lincoln Tunnel at rush hour. It's really helpful getting out of bus terminals in super crowded environments. But generally, on roads, buses need a little bit of space between them in order for a ridership to build up and be able to be helpful in moving people. However, one client asked us to look at what it would be like to operate a bus platoon that could function almost as a train. So we did that analysis, and we found different routes that might be better for them to operate, which is another way we can use this tool. What routes might be better and or preferred in terms of ease of automation? So we're doing an analysis here, including crash data and ITS equipment, intelligent transportation system equipment that's built into the road, to help try to figure out what might be some good routes or better routes to still get the people where they need to go and also have the vehicle operate well. And here's another example too. of that of another route doing that same type of operation where we've included crash data, and we found a little bit of an easier route for the bus to go. Okay, so here we are in Indianapolis, where we've done an analysis here for the I-70 border to border. So that's that's a long road, and so we see here that that it's quite challenging. And in the red, the red aspects of that road, that's largely driven by merges. Anytime two vehicles have to merge is a challenge for the automated vehicle to, without knowing how fast the vehicle is going to go, whether or not it's going to speed up or slow down, or how it might merge in. Those become challenging aspects of the road for vehicles. And I think this was for trucks. So especially challenging merging a large vehicle with smaller vehicles at different speeds and different capabilities to accelerate. All right, so Fort Worth, Texas, this was another automated bus consortium route there, and we can see a lot of that is orange. So one of the outputs for the automated bus consortium that we learned is there might be parts of the route where the driver has to take over. And you'll see on this route something I haven't showed you before. All the way to the left over here, almost at Fort Worth, is a purple segment. This is what we have what we have classified as extremely difficult. Those type of environments are largely related to GPS denied environments. So this could be a tunnel, or this could be where a lot of roadways come together and the vehicle can't access GPS. And that can be very challenging for automated vehicles. So another great outcome of what this analysis here is that the vendor of the bus would have to be prepared to operate in a GPS and denied environment in that location, or a driver, a safety driver might want to take over. Okay, I wanted to share with you as we come towards the end of the presentation, one of the big areas of discussion is the impact of connectivity on automation. So our automated vehicles, do they require connectivity to be able to operate? And the answer that we found is no, they do not. Connectivity is helpful, but not required for the function of automated vehicles. So we've done an analysis with using AV-Readi and with a company called Tech, with whom we partner. They manufacture automated buses, and here they've done an automated bus for Michigan State University. And we looked at their route, and the circles in this diagram represent the transmission of connected vehicle data from connected intersection data from the intersection to the vehicle. And so what we're looking at here, and we've not done the full analysis, but the bus is largely operating in a connected vehicle environment here. The analysis we're going to do is to see how many times the automation system changed its mind or made a decision, a change in decision making based on data that it gets from connectivity. Now, this is a super small sample size, but we want to look at that impact and see how that then impacts our analysis for how well a vehicle can operate in this automated environment. Likewise, Utah DOT has an incredible connected vehicle environment, and the leaders at Utah DOT who put this together have really been at the forefront of the world in deployment of connected vehicles, especially with regard to transit. They've had several percentage points improvement in their reliability of transit vehicles, which, by the way, the operation was already at a very high level already, but amazing that they were able to improve that using connectivity. So we've been helping them look at how much that could improve how much that could help improve the function of an automated bus in the same situation. As we wrap here, I wanted to share the outcome and some of the work that we've done about using connectivity and supporting automation. Robo-taxis, so think Waymo in San Francisco, none of those are using direct connectivity, meaning use of the 5.9 spectrum, direct connectivity from vehicles to infrastructure and from vehicle to vehicle. They are using 4 and 5G for operations, for communications back to a centralized location so that the operator can understand maybe where the vehicles are or if a route is complete. But connectivity is not being used to operate to move the vehicles, to get them from one place to the other, nor is it used to do connectivity or communication with infrastructure. So we see it operating already without connectivity in San Francisco. It'll be interesting to see if there are any improvements that can be made by adding connectivity. We're working on that. With regard to transit, some automated transit buses are using 5.9 to communicate with vehicles. Most of them are using 4 and 5G cellular connectivity to communicate with a central location, but none of these are being used for operation as far as I know. And so in about three US cities and about 10 other cities throughout the world, we see full-size buses being operated at around level 4 automation. Also cutaway buses, which are the smaller buses that would move people to and from maybe a parking or car rental facility. Some of those are automated, and transit agencies are also using automated transit. You know, in Texas is a big hub for automation, especially for goods movement. So we're seeing a lot of operation in Texas of automated trucks. Again, most of them not using the 5.9 spectrum as far as I know, but using 4G, 5G for communications for operation, not for operating the vehicle, but for feedback to and from the hub up there. And those are being used. There are level 4 trucks operating in Texas using for last mile operations and for long haul operations throughout the state as well. All right, so I'm Suzanne Murtha, as I mentioned, and that's our work on AV-Readi. I'm glad that you were able to sit through this. And then, so that's me. If you want to reach out to me on LinkedIn and ask me any questions, you're welcome to. And likewise, Paul Avery, who works for me, he's the genius behind all of this. Not me. He put my name on the patent to be kind, but Paul's the genius behind all of it. So feel free to reach out to either one of us with any questions. We'd be happy to tell you about our patent pending tool.